Hello everyone, it's Atul here, back again in another video on C programming lecture series. In this video, we're gonna talk about pointers. Pointer is a very fundamental and important concept in C programming, but a lot of beginner programmers find it difficult to understand pointers. But don't worry, after this video you will able to write your program using pointers. And all you need to know to understand this lesson, how to write a basic C program, how to declare variables, and how to do simple arithmetic operation upon those variables. So let's get started. To understand pointers, we first should understand how various data types, variables are stored in memory. So here just assume in this figure right here is a computer's memory. And we talk about computer's memory in a program execution. We mostly talk about RAM, that is our random access memory. And here we will go from lower address to higher address. Suppose initial address was given by the memory is 0 byte, and here computer increases 1 byte memory towards higher address. In this way, it takes 1 byte and it is increasing 1 byte. Okay, the computer memory by 1 byte. And let this address here, initial address, we assume here 1000, and so we increases 1 byte. So here the next address becomes 1001 and so on. So when we talk about data types, so data types are basically the properties. It tells some properties about variables. Okay, so here when we have an integer data type, so if we have a 64 computer architecture, it takes 4 bytes computer memory. If we have a 32-bit computers architecture, it takes 2 bytes computer memory. So same way, a character always takes 1 byte computer memory and a double take 8 bytes computer memory. So when we write a data type, suppose int a, so there when we declare a variable, suppose type integer, suppose we here declare int num. So num is an integer variable. Okay, so how much address it takes inside the computer memory? So it takes 4 bytes computer memory. Suppose we have started from 1000, so it will go up to 1003. So here it takes 4 bytes computer memory inside. Okay, so now we have initialized the value num is equal to 4. So it puts 4 here inside the memory and it takes 4 bytes computer memory. And again when we declare another variable, that is a character variable ch, okay, and here we initialize some value as o, character o, and it takes 1 byte memory, and we suppose it takes the address as 1004, and here we store the data o inside the computer memory. Okay, so this part basically for integer and this part is basically for character. So inside the computer memory, the address is given by the computer randomly. Okay, so here we assume that address is for integer and that address for character. But when we talk about addresses in the memory, it depends upon the computer architecture. Okay, so when it is an integer, it will always occupies 4 bytes addresses inside the memory. Now let's talk about pointers. What is a pointer? So here we know what is a variable, and now let's understand what is a pointer variable. A pointer is a variable, but it is different from normal variable. It stores the addresses of another variable. So let's understand this definition. So here you can see in the right hand side is a computer memory, and in the left hand side we have a variable and another is a pointer variable. We know that every variable has two features. First one is value, that is the data part, and another one is the address that is given by the computer memory. So here in this example we understand how basically a pointer variable is different from a normal variable. I'm first taking a pen, and now here suppose we have a variable v1, okay, and the value inside the variable v1 is 10. So this is the data inside this variable, and this 10 is our value 1 of the variable v1, okay, and here this is our pointer variable, that is p1. We assume this p1 is our pointer variable, and this is value 2 for the pointer variable. So here you can see that for this variable v1 the data is value 1, and here address is address 1, and for this pointer variable the value is value 2 and the addresses is address 2, and these addresses will be given by the computer memory randomly. And here I assume this 1004 is the address of variable v1, okay, so here address 1 is 1004, okay, and also computers addresses are represented inside the memory is a binary form, but to understand we assume it as a decimal form, okay, so this is not the exact address of this variable, we assume it as 1004, and the data inside this variable v1, that is value 1 is 10, so we have v1 is equal to 10, okay, so we have a variable v1 and which value is 10. Now you can see that this is our pointer variable p1. So here for this pointer variable, suppose since this is value is 10 and we have taken it as an integer, okay, so we have an integer variable v1, and what about this pointer? So this pointer is also a variable, okay, and here it is a pointer to integer, that means it stores the addresses of another variable, okay, and we say here it's an integer pointer, that means it stores the addresses of integer variable. So here we have v1 is an integer variable, so the value 2, that is the data inside this pointer, becomes the address of v1. So here this address becomes the value of this pointer variable, and their address is given by randomly by the computer memory, and this is address 2, and here I assume for this pointer variable p1 the address is 2000, okay, and this is our address 2, that is the address of our pointer variable. But when we talk about the value, the data part, so here you can see that this data is 1004, that is the address of which address of variable v1. So here you can see that a pointer is a variable which stores the address of another variable. So a pointer variable has some special features, but likely a variable it has also two features. First one is the value and another one is its own address, and also the addresses are represented inside the computer memory in a binary form. So let's know how can we declare a pointer variable, and let's talk about pointers declaration and initialization. So we know that pointer is a variable which can store the address of another variable. So here you can see that we first write a data type, and after that we write a pointer variable name. So here pointer variable name is written as same for the variable name, but you can see that there is a asterisk before a variable name. So when you declare a pointer, you have to write a asterisk before a variable name, and also some programmers used to declare in this way: first a data type, then this asterisk, and after that the pointer variable name. Now let's understand what are the information comes from this declaration. So here you can see that suppose if we have an integer a, so we can say that this is a is an integer variable, and when we declare int star ptr, that means we say here ptr is a pointer integer that point to a integer variable, that means a pointer to integer. Okay, so it basically stores the address of integer variable. Same way when we have a character variable, then we say it a character variable. When we have a character pointer, that means a char star ctr, that is a pointer to character. Okay, we can say it a pointer to character. Same way if we have a double data type and these are double variable, we can say it's a double variable. When we used to declare a double pointer, so when we put a asterisk before a pointer variable, we can say it a pointer to double. Okay, so in this way we can say a pointer declaration. Now let's talk how basically we represent a pointer and how we stores the address of another variable inside the pointer. Okay, so I'm gonna first open Visual Studio Code. So here, okay, so it was already there. So I'm just gonna delete this part. Now here, first of all, we're gonna write h include stdio.h. Already you know what is the meaning of h include stdio.h. After that, we're gonna write int main, and then here. Okay, so first we're gonna write a variable name. Int a is equal to 10. Okay, so this is our integer. A is our integer variable, and here we again write int star ptr. Okay, so ptr is nothing but a integer, an integer pointer. Now we have to put the address of another variable. Since int is a integer pointer, so we have to put address of any integer variable. So how can we assign the address of a variable inside the pointer? So we know that we has an ampersand. Okay, so here we're going to write in this way ptr is equal to ampersand a, that means address of a. Okay, so now we're going to print this pointer using a printf function. Okay, printf percent %d, here we're going to put a space. Okay, put a backslash. Here what we're going to print here, we're going to first print here address of a. Okay, so what is address of a? So here address of a is basically is a hexadecimal or a binary number which is basically given by a computer. Okay, so in computer memory, so it is randomly given by our computer. And now we will print a pointer p. So what is the value of ptr? So can you tell me what is the value of this ptr? Okay, so since we assign the value inside of ptr, and here our ptr is a integer pointer, that means it stores the address of an integer variable. So pause this video and guess the output. Okay, so here I'm just gonna run this C program. Okay, so here you can see that this 642296 is the address of A, and also when we print the value of that pointer, that basically gives the value of PTR, and here the value of PTR is ampersand A. So now can we access the data, the value of A using this PTR? So yes, we can assign this value using this PTR. Okay, so how can we print the value of a, that is the data of a, using this pointer variable in line number 6, that is a PTR? Okay, so here see in the comment Okay, I'm just gonna write here above the hatch include story.h. So we have this asterisk, okay, and this is basically known as also a dereference operator. So it is also known as a dereference operator. Dereference operator. Okay. So when we use this operator before a pointer, it will dereference the address. That means you can understand in this picture. Okay. So here, this is your pointer variable, that is our PTR, and there that variable is a. Okay, and a is our variable. Okay, so this address is basically that value 2. Now let's talk about this operator, this dereference operator. This is your asterisk, and when we write here a PTR, okay, so when we put this dereference operator before a pointer variable, what is the meaning of that? Okay, so when you write a pointer variable here, okay, so when you write a pointer variable here, that is a PTR is here, so you are actually here at the address of that variable, this variable a. So here our PTR is equal to ampersand a, that means address of a, and a is our integer variable. So now when we put this dereference operator, that means we can go inside this a variable. So it will give us a value of a, and also we can change the value of a with the using of this asterisk, that is a dereference operator. Okay, so here we can access the value of that variable using the address. Okay, and also we can change the value of that a variable. Now again, let's open our Visual Studio Code. So here this is our dereference operator, and now we're gonna put here, this is our a. So we're gonna here print a value, that is printf %d, also a backslash n, and here put star. That star is our dereference operator. Okay, and here also we're gonna put a backslash n, and okay, so write your return 0. Otherwise, it will work fine. So here you can see that we're gonna use this dereference operator to print the value of a. I'm just gonna save this C program and run this. So you can see that this value 10 is nothing but the value of a, and also you can change the value of a using this operator, this dereference operator. Okay, so I'm just gonna put the value star ptr is equal to 20. Now I'm just gonna print the value of a. Okay, so here %d backslash n and put a comma and that a. So previous value of a was 10, you can see in line number 5, and here we're gonna update the value of a using this pointer variable, okay, with the help of this dereference operator. And here we can see that what is the new value of a. So again, save this C program and run this. Okay, so we have to put a semicolon. Okay, it was already there, I think. Okay, so again I'm just gonna save this C program and run this. So you can see there this value is 20. Okay, that is a value of a. So you can see the value of a can be changed with the help of a pointer variable. That means address. Again I'm just gonna print the address of a. Okay, so the address remains same. Okay, so address remains same. So here you can see that that address, that is a 642. Okay, that is this address, and this address remains same. Okay, so that means we just change the value at that address using a pointer variable. Okay, So this is all about the introduction and declaration part of a pointer variable. And now also I have mentioned that some programmers used to declare a pointer in this way. They first write int star then a ptr. Okay, so again I'm just gonna run this C program. It works fine. Okay, so it will not give an error. So this declaration and also this declaration int star ptr both are same. Okay, so you're gonna use these two declaration anywhere. Okay, so I'm just gonna use this one. So in the next part we're gonna talk about pointer arithmetic. Okay, so let's start. Do some operation with pointers. Okay, so can we add any numbers, integers to the pointer? Can we subtract any value? So let's see. So here I'm just gonna first delete this part, and this will print you basically the address of A, that is ptr. And in the next line I'm just gonna print size of A. Okay, so what is size of A here? Since I have a 64-bit computer architecture, so it will take 4 bytes computer memory. So it will print 4. And what happened when we're gonna add some new value to the pointer? So what is the output right now? Okay, so can we add a number with pointer? So I'm just gonna save this and again run this C program. So here you can see that okay, so let me give a backslash n after that. So you can see that first it prints the value. Okay, so here you can see that this is your okay. So now 642296, it is address of A which gives by ptr. Okay, that is our pointer variable, and 4 is the size of A. And in the ninth line you can see we add 1 with ptr, and ptr is the address of A. So if this is a normal variable, that the next value will be 6297, that is 6422297, but here this is 642300. Why? Because you know that integer takes 4 bytes computer memory. So if the previous address was 642296, here we have previous address 642296. So when we add it, it takes next 4 bytes computer memory. That means 1. Once means the next byte. Okay, so since each integer takes 4 bytes computer memory, so when we gonna add a plus 1 value, it will give the next value after that. Okay, and same way, suppose we're gonna just subtract any value, it will give us the previous value, that is 292. So you can see we're gonna add and subtract any integer uh, inside of pointer. Okay, now I'm just gonna ask you, can uh, can we subtract two pointers? Okay, so here I'm just gonna write a pointer. Okay, so suppose we have a pointer int star ctr. This is another pointer, and here, and we're gonna write int a1 is equal to 100, and we're just gonna write ctr is equal to ampersand a1. So here I'm just gonna ask you to, can we write here in this way, like cd backslash n and put a comma, and here ptr minus of ctr. So is that correct, or what is the output? Pause the video and guess the output. I'm just going to run this. So you can see here the previous value of that was 642292, and the next value of this was 64228. But here you can see the subtract value, that is that the value is 1, and that is basically the offset value. Okay, and here we're going to just print the data, that is the value of ctr. Okay,
and just write here CTR and put a semicolon, line number 13. And now again, so here the value of the address, okay, so previous value was 642292 and the new address is 642288. For what? For this CTR. Here the new address has been given to the pointer, and when we subtract these values, these addresses, okay, and I'm just gonna comment this, so it will give us the offset value of two addresses. Okay, first of all I'm just gonna save this and again run this. Let's wait for a few seconds. Okay, so now here we have 642292, that is a pointer, that is address of A, then after 4 that is size of A, and after that we have 642288. It is basically the address of this A1, okay, and after that when we subtract pointers from the second pointer, it will give you 1. Why this 1? Okay, so here in this way, if we subtract some values from a pointer, it will give us some values, but here this is 1. This is basically the offset value. Okay, so here you can see that the address of PTR is 642292 and the address of CTR is 642288. So this is the exact address, that is the difference between these two addresses, 4. Okay, that is 4 byte, and we know that a 4 byte is basically represent a 1 integer data type, so it gives us 1. Same way, when we add 1 to the pointer PTR, it will give the to the next address. Same way here, 4 byte, when we subtract two pointers, it will give the equivalent bytes of that pointers. Okay, and also when we're going to subtract two pointers, we have same kind of pointers, otherwise it will not give the exact value. Okay, so again you're gonna ask me, can we add two pointers? So here I'm just gonna add two pointers. So what will be the output? But here it does not make any sense. We cannot add two pointers. What is a pointer is basically the address of some variables. And you're gonna add the address of another variable. But when you subtract two addresses, so it will give you the equivalent offset value of the bytes. Okay, but when you're gonna add this, it will give you a compilation error. I'm just gonna save this and run this program. So it will give you an error. So we cannot add two pointers. Okay, so here we can only subtract, and this subtracts when you're gonna subtract the two pointers, it will give you the equivalent size of a byte. Suppose the difference is 4 byte, that means it will give you 1. Why? Because we use here integer. Okay, and now what happens when we're gonna assign? So here we have CTR and we're gonna assign a value, a pointer, that is a PTR inside CTR. So what is meaning of this assignment? This means a PTR is a pointer of integer which stores the address of A, and also CTR is an integer pointer which also stores the address A. That means this PTR and this CTR, these two pointers, points to the same addresses. Okay, so we can assign in this way. So here when gonna print the value of CTR, that is star CTR, okay, so it will give us the value of A, that is 10. Okay, so we can assign our pointers in this way. So this is all about pointers arithmetic, guys, and the next part we will discuss about type of pointers. What is a null pointer? What is a void pointer? So okay, so let's see. So now let's talk about different types of pointers. So here we first gonna discuss wild pointer. So what is a wild pointer, guys? So when you declare a pointer without any initialization, that is known as a wild pointer. And this type of pointers are not efficient because they may not point to some unknown memory location and which may cause problems in our program and it may lead to crashing of the program. So you have to always careful to write a pointer. So you have to always initialize it. So here I have created a pointer int star ptr and we not we do not here initialize any value inside this pointer. So this is known as your while pointer. When you only declare a pointer without any initialization. Okay, and when you're gonna run this C program, so here, so it will give you some value. That value is basically randomly given by the computer. Okay, so here address is fine and it was given randomly by the computer, but sometimes it will give some unknown memory address, so it may be crash our program. So now let's talk about null pointer, guys. Okay, so how can we solve this problem of wild pointer? So let's talk about null pointer, guys. So we can create a null pointer by assigning a null value during the pointer declaration. So here in the line number 4, we have declared a pointer int star p is an integer pointer, and here we are assigning a value null. So null is a string which is equivalent to 0 in C programming, and also it is used in various programming languages. So here this is known as our null pointer. Why we gonna assign this value inside this p? So since this method is very useful and we don't have any address assigned to the pointer, so we can easily use this pointer as null. And after sometimes when we're gonna use some addresses in our pointer, at that time we're gonna use this p. So why in the beginning we're gonna assign this null value inside the pointer, and also it's gonna help us when we're gonna have a wild pointers, we can avoid it using this null pointer. And when you're going to save this C program and run this, you're going to see that. So here the value of P inside is 0000. That is the equivalent to null. And here we're going to use a percent %p. So if you want to directly print the value inside a pointer, then you're going to use this percent %p. Otherwise, we have to write star p. Okay. Now let's talk about wide pointer, guys. So what is a wide pointer? So in C programming, wide pointer is also called as generic pointer. So it does not have any standard data type, and we're going to use a wide keyword here. You can see that in line number 6. We have used a wide keyword before this p pointer to create a wide pointer. So here there is no any data type for this wide pointer, guys. Okay, so we're gonna assign this any value of any data type inside this pointer, and we're gonna use this wide pointer as a integer pointer, as a double pointer. It's up to you. So here we have a variable int a is a variable, and we have assigned a value 10 inside that. That is an integer variable, and you can see there we are basically here typecasting this p, and previously p was a wide pointer and now it is an integer pointer. Same way we are typecasting here double star p, and the previously p was a wide pointer, it was right now a double pointer, guys. So we're gonna use a wide pointer as integer pointer as a double pointer. Okay, so initially when we do not know what is the type of a pointer, then we can easily assign a pointer wide using a wide operator. And also it's better to use, you have to just write a null. Okay, so it is also a null pointer and a wide pointer. Now I'm just going to save this C program and run this. So here you're going to see that the integer variable is 10. Okay, so the spelling, okay, you will correct it, the spelling of variable, and also the double variable is 3.500. So this is all about the type of different types of pointers, guys. Also we have different kinds of pointer like dangling pointer, use pointer, bad pointer. Okay, so you have to only understand this kind of concepts. And now in the next part, we're going to discuss about pointers to pointer. Okay,
Let's talk about another part of this chapter, that is pointer to pointer. So what is a pointer to pointer? That means a double pointer. So what is meaning of this double pointer? So basically, a pointer to a pointer is a form of a multiple in direction or a chain of pointers. So here we have mentioned a chain of pointers. We have multiple pointers which are connected with each other. So normally a pointer contains the address of a variable. Okay, but a double pointers, so which is a pointer to a pointer, so it used to store the address of the variable and the second pointer, that means that double pointer, it is used to store the address of the first pointer. So we have two pointers here. First one is our normal pointer and another one is our double pointer. And the first pointer usually stores the address of a normal variable, but a second pointer used to stores the address of the first pointer, and that second pointer is known as a double pointer. Now, how can we declare this double pointer? So, declaring a pointer, a double pointer, is same as when we declare a normal pointer, but here we use one extra asterisk before a pointer name. So here you can see that int star star pptr is our double pointer. Now let's understand these things, how basically all these pointers are represented in a memory. So let's open the next page. So here you can see that we have a variable where. Okay, so where is a integer variable and here value is 6, and you know that for every variable there are two features. First one is the value part, another one is the address part. Same way we have a pointer variable. It is not a normal variable, it is a pointer variable, and it stores the address of where, that is our integer variable. Same way we have another pointer variable, and here this pointer variable is not a normal pointer, it is a double pointer, guys. So it stores the address of another pointer. So here this is the address of, basically this stores the address of this pointer. So you can say that that address is basically the value 2, and this address 2 is basically this value 3. Okay, so here actually this is value 3. Okay, so you can see this is basically a chain of pointers. Okay, so this is your pointer first and this is your second pointer, guys. And now what happens inside the memory? Okay, let me make this 3. It was some, okay, so sorry. Okay, take me some eraser. So here, one minute, guys. Okay, yes, yeah. So this is our address 3. Okay, and this is our value 3, guys. Now you can see that suppose the address of variable var. Okay, so I assume here address 1 is 1000. Okay, that's nice. And now what is address 2? And also I assume the address of this pointer is 1010. Okay, nice. And also since this double pointer is also a variable, okay, so also it has two features. First one is value, other is their address. Okay, and I assume the address 3, that is address of this double pointer is 2000. Okay, nice. Now this is our memory in the right hand side, and this is our lower address and this is our higher address. Also memory address is increasing from 0 to higher address. Okay, by bit by bit. So I assume there this is 1000 address, and there are so many addresses between them, 1000 to 1000, and here also there are a lot of addresses between 1010 to 2000. And now we stores the value 6 inside this address, that means this variable.
So here you can see that this is our value 6 of this var variable. And after that, for the pointer, this is our pointer which stores the address of this variable. So here the address of this variable is 1000, and here you can see that this is 1000 stores here inside the pointer ptr. And also there is a double pointer, guys, and it actually stores the address of this pointer, this ptr. Okay, so for this pointer behaves as a variable for this double pointer. Okay, like this, a variable var behaves as ptr, same ptr behaves for double pointer pptr. So here for this pptr, that is a double pointer, the value is 1010, and this value is nothing but it is the address of this pointer ptr, guys. And the address of this double pointer is 2000. If we have further a next pointer, that is which can stores the address of double pointer, we can also write there, and also so on. So here we have a 2000, somewhere we stores the data 2000, and also some addresses there. Okay, so this is looks like a pointer chain. And now we're gonna understand this double pointer or pointer chaining by our simple program. So let's first open Visual Studio Code, guys. I have already created a file name, double pointer.c. Okay, I'm just gonna okay, double pointer.c. If you don't know how to create a file name, just go here and create a new file and write the file extension .c. And now I'm just gonna take a variable int var is equal to 6. This is our normal variable. And here I'm just going to take another pointer, that is int star ptr, that is a pointer to integer. And here this pointer basically stores the address of that var variable. Okay, and then after we're going to declare a next pointer, that is a double pointer, guys. I'm just going to write the name of this variable pptr. Okay, and here this pptr, that is a double pointer, can stores the address of other normal pointer. So here pptr is nothing but it is address of ptr, guys. Okay, so now you can see the pointer chaining here, how basically double pointer stores the address of previous pointer. Okay, and now I'm just going to print the value, guys. So here we want to print this value var 6. Okay, the value of var variable is 6 using ptr pointer and also pptr pointer, guys. Okay, so what we're gonna do, we're gonna just write printf, that is a printf function. Okay, and here I'm just gonna write a %d, and before that I'm just gonna write value of var. Yes, value of var. Okay, I put a backslash and then put a comma here, and after that I'm just gonna write a var. Var is our variable. I put a semicolon. After that I'm just going to write a printf, and now that is again value of var but using a pointer. So I'm just going to write here only using ptr, and just put a backslash and here you know that how can we print the value of a normal variable using their pointers. So we're going to use a dereference operator. So here that star is a dereference operator, and we're just going to write a pointer name, that is our ptr, and put a semicolon. Same way we're going to just copy this and print, paste it. Okay, so here I'm just going to use the pptr pointer, okay, to print the value of var. So how can we print that value using this pptr, guys? Okay, so this is our pptr. So since we're gonna use here only single star asterisk before pptr, so it will gives the value of ptr, guys. Okay, so it will only give the value of ptr, that is address of var, but we want to print the value var. Okay, so we have to put another asterisk before this. So here we're going to use two dereference operator to reach at the variable where. I am just going to write here a return 0 guys. Okay, now here I'm just going to save this C program and run this. Okay, so here excuse me guys. Okay, so we have actually not printed any value, sorry. So percent %t, and here also we have %t. Again run this. So you can see that all values you can print using double pointer also and a pointer also. Why we gonna use this double C star pptr? You're gonna say that. So here I'm gonna print it only ptr and also star pptr. You're gonna say that these two values are same. Why same? Because ptr, that means the address of where variable, and star pptr, that is when you gonna dereference pptr. And here this pptr basically stores the address of this pointer pptr, that means this pointer ptr. So why we're going to use directly in this way. So this is all about double pointer or pointer to pointer guys. Okay, also we're going to use a third pointer. We're going to assign the address of this pptr also. Okay, so in this way we're going to make a long chain of pointers. Now we're going to talk about pointers and arrays. Okay, so let's see. Now let's talk about a pointer to array or an array pointer guys. Take a break, or after that you can just understand all these things very seriously. It is very easy, but you have to focus. So what is pointer to array and array pointers? So here I have already created a file name, pointer to array.c. Okay, and now just understand line by line. So in the line number 4 I have created a array with size 5. We don't need to explain these things. We have already made a separate lecture video on array. So this is array, an array variable named arr of size 5, and the array elements are 0, 2, 3, 4, 6. And here I'm just going to print the value of first element, that is arr0. And since each array element behaves as a variable, so you're gonna print ampersand, that means the address of arr0, that is the address of first array elements. So I'm just gonna use ampersand before an array name. And also here you can see that in this line number 8, what is that? Okay, so here we're gonna print arr, that is the name of an array. So listen and understand carefully. So here this ARR guys, okay, so this ARR guys, so ARR basically is the base address. That means it is the address of first element. Okay, so what is the address of first element? That is ampersand ARR0. Okay, and here ARR is also the address of first element. When you're going to write the address of second element, you're going to write here ARR1, that means ampersand AR1. Same way you're going to write ampersand AR2 for the next element, and so on. So here the same way we're going to write here ampersand ARR0 for the first element. Okay, but when we're going to use only this array variable name, it behaves as a address of first array element. Okay, and it is by default, it is the address of first array element guys, and it is also known as the base address of an array. I'm just gonna save this C program and run this. You're gonna see the address of these two array elements is same. Okay, I think there is a missing semicolon or something like that. I'm again gonna save this and run this C program. So here you can see that this is 0, that is the first array elements here in the line number 4. This is our first array element, that is 0 guys. Suppose, okay, suppose it is 10, so it will print us 10. So here this is 10. And now the address of first array element is 642284. Okay, and also when you're gonna see in line number 7, we will print only ARRR, and that is the same address which was assigned to the first array elements. Okay, so the ARR, that is the name of an array, is a base address by default. Okay, and I'm just gonna print the next address. Okay, so here I'm just gonna copy this again, paste it. So this is the address of first element, this is the address of second element, and again run this C program. So here you can see that each address is the difference between these two addresses is 4 byte, guys. Why? Because you know that here array, this is an integer array. Okay, and when we stores the element inside the array, it stores at in a contiguous memory allocation. Okay, suppose the address of first element is given 1000, so the address for the next element becomes 1004, and same way for next is 1008. So in this way, basically array elements stored inside the memory. Okay, so why you're gonna see that array of one, address of one, and address of two is related. And now the question arises, how can we use pointer to an array? Okay, so here I'm just gonna tell you, suppose you're gonna declare a pointer. Okay, what we have knowledge about pointer, we know how to declare a pointer. So I'm just gonna declare a integer pointer, int star ptr. Okay, so that is basically our integer pointer, guys. Okay, I'm just put a semicolon there. Now you know that you're gonna assign address of some variable inside a pointer. Okay, good. So in line number 13, you can see that I'm just gonna write a ptr. Okay, so here I'm just gonna write ptr is equal to ampersand. Okay, I'm just gonna assign here the address of first array elements. You know that array elements behaves as a variable name. So here AR0 is nothing but a other, like other integer variable. Okay, so you're gonna see there ptr is equal to ampersand ar0. Is that correct? So yeah, you're absolutely right. Why? Because it is same as a variable. Okay, so I'm just gonna print here the value of ptr, guys. So you can see, so here, I'm just gonna print what, star ptr. Okay, I'm just gonna save this C program. So what is the value of this line number 40? Okay, so you're gonna save me output, pause the video and think about the problem. Okay, so here this ptr is an integer pointer. Okay, and this is an integer array, and each array elements behaves an integer variable. Here you assign the address of integer variable AR0. That is, this pointer is a pointer to this array element. That is the first array element, guys. And here you just gonna print the value of that ptr. That means the value inside this ptr, because you are using a dereference operator. That means the value of arr0. So I'm just gonna save this C program and again run this. So here 1 minute. Okay, so there is some error here. So int star ptr, that's good. Ptr is equal to ampersand ar0, put the same comma. Okay, again save this and run this C program. So you're gonna see here this value is 10. Why? This is exactly the value of our first array elements. Okay, and now here, can you write in this way, that is ARR? Is that correct? Yeah, absolutely, it is also right. We're gonna write in this way also. Why? Because you know that the array name, that is ARR, is nothing but it is equivalent to address of first element, guys. So it is nothing but it is equivalent to address of first element. Why? Because this is your base address, guys. So it is equivalent to the address of first element. We can write in this way also. So now I'm just going to save this C program and again run this. So here you can see that, okay, so 1 minute guys. So here you can see that this is again the same value, that is 10. And now that means they're going to use pointers instead of array. Okay, so we can use pointer inside an array. Suppose we want to print the value of second element. Okay, and also you know that array elements are stored inside a memory at contiguous memory allocation. Okay, continuously. So here ptr is a pointer of an array and it stores the address of base array elements. See, how can we access array elements using pointers? So here you understand ptr is a pointer of an array element. So now also you know that array elements are stored at contiguous. Okay, so they are stored inside a memory contiguously. So since it is an integer pointer, so the address of first element is 1000 and address of next element is 1004. So here we know that this ptr is the address of first element. So suppose we want to print the next address of array elements. Can we write here ptr plus 1? Is that correct? So tell me the output. Pause the video and think. So here, suppose you want to print only ptr. So it will give you the address of first array elements and here and since this line is equivalent to, okay, I'm just going to write here. This is equivalent to line number 13 is equivalent to line number 14. So don't be confused between them. And this array name ARR is nothing but it is the base address, that is address of first array element. Okay, it is by default. So we can use in person ARR0 instead of array first element address. Okay, now understand what is the value of ptr1. So ptr basically gives you the address of first array elements and what is the meaning of ptr plus 1. So in the previous part we have discussed about what happens when we add elements to a pointer. Okay, so it basically increase by byte depending upon the data type. So here this will increase the value by 4 byte, that means one integer for the next for one integer. So here suppose address is 1000, so the next address become 1004. I'm just going to save this and run this C program. Okay, so here 1 minute guys, it is now it is correct. Okay, so here you can see that there are different addresses here and in the last two address the first one is 280 and the second address is 284. Okay, so that is ptr1. So it is nothing but it is, we can write here ptr plus 1 is equal to, okay, so you can see here that is 642284. So in this way we can access each and every element of an array. Suppose we want to print fourth element. So I'm just going to write here 4. That means the address of 4 element guys. Okay, so here you can see that is 296, that is address of fourth element. Now can we print the value of this array element using pointers? Yes, why not? So here I'm just gonna print write a dereference operator. So this part is for address. I'm just gonna write here. Okay, so just write it in this way. Address will be, and now here again here. Okay, so read this part. Again I'm just gonna write for value of array elements. Okay, in line number 90 and 20. So only see this line. So here in line number 19, sorry 20 and 21, you can see that how can we print the value of first element. If you put a dereference operator before a ptr, it will give you value of first array elements. Okay, so this is our array element, guys. I'm just gonna write this array element here that you can see this. Okay, so this is our array elements. Okay, now just take a look here. So here we have put dereference operator before ptr, and it will give you the value 10. So how can we print the value 2 using this dereference operator, guys? So if you put a dereference operator before here, and suppose you want to write here 1, so think about what is the output of this program. So it obviously 2. Why? Because ptr1 means that is the address of 2, and star ptr1 means the value at that address. This is a dereference operator, guys. So here ptr1 prints the address. Okay, so I'm just gonna again write here. So in this way. So that is ptr plus 1. Okay, and here just write to understand. Okay, so here I'm just gonna write here. This is address of second element. Address of second element using ptr, that is a pointer, and here I'm just gonna write value at this address, value at this address ptr plus 1. Again save this C program and run this. So you're gonna see there that is 642296 was the previous value, but here this 10 was the value of ptr0, that is a ptr, that is a value of first array elements, and here the address of second array elements is 642284, and the value of this address is 2, guys. Okay, so you're gonna see in this way, that is okay. I'm just gonna zoom out. So value at this address. So if you want to print a third value, guys, okay, so you're gonna write here 2. Okay, so it will give you a third value, guys, and also the third address. So that is 3. That is the third array element. So you can understand in this way how can you access array elements. Okay, so I'm just gonna zoom out this. 1 minute, guys. I'm just gonna zoom out this, and you can just take a screenshot or pause this video or make a note. Okay, and after that I'm just gonna zoom in. So here I'm just gonna delete all this part. Okay, and here also. If you don't write, didn't write yet, just go back in the video and pause this video and write all the things. Now make it simple. We have learned a lot of things, so make it simple. So here, so how can we use pointer inside our program when we use an array? So we first declare suppose array elements, and we want to print our array elements using pointers. So I'm just going to write a printf statement, array elements using pointers. Okay, so write a backslash and here and put a colon. Okay, line number 8. Now, so you want to print all the array elements using pointers, and here don't confuse that this ARR. What is this ARR? This is nothing but this is address of first element. Only applicable for first element, guys. This is address of first element. So I'm just going to use since you have assigned the address of first element inside the pointer, you can access each and every element using this pointer. I'm just going to write a for loop int I is equal to 0, and since the size of an array elements here is 5, so I'm just going to write here 5 and I plus plus. Now just going to write printf, okay, percent d, comma, and put a semicolon. So what we're going to write here? So we want to print the value. Suppose we want to print first value using pointer. How can we write here? We're going to just write star ptr. So star ptr is the value of first array element, and this is nothing but we can write is sorry this is in this way, that is plus 0. Okay, so can we write ptr, that is a star ptr, in this way, ptr plus 0? Okay, so this is basically our first array element in line number 11. I'm just gonna put it on middle. So here, if you want to print second array elements, that we're gonna write here ptr1, and we're gonna put a dereference operator before that. It will give you the value of that address. Same way for third element, for four element, and for five element. Since we're gonna use a for loop here, basically a looping statement. So I'm just gonna write here I. What is this I? This is nothing but this is a variable inside this for loop. Okay, and when this loop runs, the value of I will update as 0, 1, 2, 3 up to 4. Okay, and so on, and this will print our array elements, guys. So here 10, 2, 3, 4, 6 are our array elements. So you can see that how can you use a pointer inside our array. Okay, also you can use pointer in a multi-dimensional array. You can take inputs from the user using a pointer. Just replace so here I'm just going to write one thing. So how can you understand what is the value? So here if ARR is 0, what is equivalent of this inside a pointer? It is nothing but it is a star PTR plus 0. Okay, it is nothing but it is plus 0. So what is equivalent of ARI? So you can write here this is nothing but plus I. Same way, what is equivalent of ARRI? That is PTR plus I. Okay, so this is equivalent to this address of this array elements, and this star PTR is plus I equivalent to array elements. Okay, so in this way you can understand the relation between pointers and array elements. Okay, so now how can we take inputs from the user using pointers? So simply when you use a scanf, I'm just going to write here a single line. You can do it by your own. Just write scanf percent %d. Okay, and here, so since you have to take input from the user, okay, so what we're going to write when we're going to use take input from the user, we're going to write here ampersand ARR and that I, okay, for inside the for loop. So we're going to use this statement and we want to replace it by pointer. And this ampersand ARR is nothing but this is PTR plus I. Just going to replace this by PTR plus I. So just write this statement and you can take input from the user inside a for loop. So you can use this statement to take input from the user. Okay, in line number 13. And now this is all about pointers and arrays. And also, can we declare an array using a pointer? So yes, why not? So here you can see that. So here I'm just gonna delete all this part, and if you didn't make a note, I'm just gonna zoom out. You can make a note or screenshot, take a screenshot here. Okay, so I'm just gonna first delete all these things. Now how can we declare a pointer array? So the general syntax for declaring. Okay, so sorry about the spelling, guys. Declaring array using pointer. Okay, so here what we have to do, we will just write a data type as usual. Data type, that is, maybe this is int and this is char anything, and after that we're going to just put this asterisk, and after that a pointer variable name. You can write here a pointer name, and here just put the size of an array. You can write here size of array. Maybe it is 5 in our previous example, like previous example. So you can declare an array in this way, guys. Okay, so now here suppose we want to declare an array of 10 size using pointer. You can write here int star ptr. You can use another variable instead of ptr. You can use ptr ctr. Okay, so you can write here in this way, and just gonna write here array of 10 size. Okay, so this will allocate uh, 10 integer, for that means 14 bytes, 40 bytes. Total number of bytes is 40 inside a computer memory, since it is an integer. So here this ptr is an array of. Okay, so this basically declares. So here this ptr is a pointer that can point to array of 10 integers. So in our previous example, that pointer is only pointing to the single element, guys. Okay, so that was pointing only the single array elements, but here this ptr is pointing to the whole array of 10 elements. So now see what is actually the difference between this ptr and our previous example. When you declare array in this way, so this is our declaration of an array using a pointer, and here I'm just gonna create another array. This is a normal array, int arr, and here this arr is suppose 3, and here I'm again create a write a pointer p. Okay, so this p, and when you're gonna write p is equal to arr, that is our array, that is our new array arr. So this is different. This statement and the line number 6 statement is different, guys. What is the difference between these two lines? So here this ptr, that means this p, sorry, this pointer is pointing only to the 0th element, that is for the base address element. This p pointer points to 0th element. Okay, but this ptr points to the whole array of size 10. This ptr is pointing to whole array of size 10, guys. So this ptr is pointed to whole array of size 10. So this is the basic difference between these two lines. Okay, so this p is only for the first array elements, and this ptr is pointing to the array, suppose some array of 10 size, to whole array of size 10. So that is the difference between this pointer and this pointer. So now also this is totally different. You can see in this way, this is for only the first array elements, and this ptr is for all 10 array elements. Suppose I'm going to write here 10. Okay, so this is pointing to the array of 3 elements, and this p pointing to the only the first array elements. Okay, and now here, now you must understand by this example. Again, I'm just going to write here Suppose you're gonna assign a value inside this ptr, that is AR. Okay, and also you're gonna assign the value here. Suppose I'm just gonna write a 10. Okay, so make why, because here I'm just gonna assigning ptr is equal to ampersand ARR. Okay, so that is points to the whole array. So here ptr pointer points to the whole array, guys. Sorry, whole array. So here this ptr points to the whole array. And now suppose you're gonna print the values, printf and percent d. Okay, and that is the address of first array elements, that is p. I'm just gonna write address of first array elements, first array elements is equal to percent p. That is nothing but that is p, like in our previous example. And again the address of this is a first array elements. Also, when you're gonna print the address of ptr, that is also gives the address of first array elements, but this contain the total 10 array element, 10 array. Okay, this points total 10 array. Now see the difference. Okay, so this also gives the same address of first array elements, since the whole array and also the first array elements starts from the same address, so you can write here address of first array elements, or uh, or you're going to write here address of array ARR, array ARR. Okay, and now again I'm just going to print the same statement twice, but this time I'm just going to write increase each address by one, guys. So what should be the output? Okay, here I'm just going to write next address, and also here next address, next element address. So you can see here I'm just going to save this C program and run this. So now here, look, take a look here. Okay, so the address of first array element is 644256, and address of whole array, since first array element is also the base address of whole array, so also these two address is same, guys. But when we talk about the next address, when you're gonna add 1 to the next address, so it will give you 60. So here, since we have 56 is the first array address, and the difference between two this address is 4. Why? Because this is address of next array elements, and we have integer pointers. So integer basically occupies 4 bytes. So the next element address is 60 to 60. Previous element is same. But when you talk about the next address, that is the address of whole element, that is exactly 296. So when we're going to add 40 to 256, it will give you 296. That means this pointer occupies array. Okay, so array of 10 size. Okay, when we're going to add address 1, so it will give the next address after 40 byte. Okay, so it occupies the next address after 40 byte, and this pointer p only occupies for 0th element. When we talk about the next address, so it will give the next address after 4 byte. Okay, so that is the basic difference. I'm just gonna zoom out. So that is the basic difference between a pointer which points to the whole array and a pointer which points to the zeroth element. You can understand in this way. Okay, so also we can calculate a size of this pointer. So we're gonna use a size of operator. So you can see what is the total size of this pointer. Size of pointer p. Okay, p here, and size of ptr. Just gonna write size of pointer ptr. Okay, and since we want to calculate size, so we have to use size of operator. Okay, so here this is our size of operator, and also here we have to write a size of operator. Now save this. Okay, and just gonna run this C program. So here a size of pointer p is 4 and size of pointer ptr also 4. Since these are integer pointers, so this size basically gives the exact size of pointer. Okay, so not the data inside that pointer, the size of data inside the pointer. So since these two are integer pointers, so why this gives us same size 4. Suppose we're gonna print here, right here, star ptr and star p. So now you're gonna see the differences. Okay, so here size of p, pointer p, that is the data of inside the pointer p is 4 and size of pointer ptr is 40, guys. Okay, so this pointer, that means this ptr is pointing an array of 10 elements which occupies 40 byte size, and this p only occupies 4 array elements, sorry, only the first array element, and it occupies 4 byte memory. Okay, so you can see the differences in this way. And this is all about pointers and array, guys. Also you can use pointers to two-dimensional array. Okay, so in the next lectures, when we're going to discuss the first functions, array and functions, and after that we're going to discuss array, functions, and pointers. Then we're going to discuss these things also. That means a multi-dimensional array, pointers, and also function. So thanks for watching, and if you like the video on C programming, pointers, you can share this video with your friends. Also, we're going to cover a lot of new subjects like data structures and algorithms. We're going to cover Java programming language, object-oriented programming language like Python. Also, if you want to become a developer, very good developer, you want to learn full stack development, you can subscribe our channel. In the upcoming days, we're going to cover all these topics on our YouTube channel. Okay, so just connect with us, and thanks for watching and keep learning.